Hello everyone, I'm doing this video to explore some of RAOUL Hatem's work on the atom and show people that particles are not charged, and simple experiment you can try at home. Maybe you have a magnet somewhere, you know, the instrument which attracts nails or pins, which closes your cupboard doors. If you have one, hold it between your fingers and bring it towards your other hand and see what happens. I've got some magnets here, pretty powerful magnets. So I can bring them towards my hand, and let's see, nothing happens there, nothing happens there, and nothing happens there. Is your hand still there? It didn't disappear, reduced to dust? Perhaps you do not understand our experiment. Maybe you have learned in school that matter is composed of positive and negative or neutral atomic particles. You also know that magnetic fields deviate particles from their orbits. Electrons is the name of negative particles and protons the name of positive ones. So when you bring your magnet toward an object, its magnetic fields, if positive on this side, will attract electrons and repel protons. Isn't that so? If it's positive on this side, we'll say. You turn it round and it repels electrons and attracts protons. So why does your hand remain a hand? How can this be possible since the particles are disturbed by the magnetic field? All atoms close enough to the magnet should be destroyed. Not close enough, you think? So take a very big magnet, a huge magnet if you like, and put your hand on it. It's still a hand in good health. And I know they've levitated frogs in very highly magnetic fields, and it doesn't hurt the frogs. Ask a physicist why this is so. He will answer that the equilibrium of the forces within the atom prevents its destruction. This is incorrect. If electrons are negative, they are attracted by the protons. If they do not follow protons, it means that something keeps them in their orbit with a power exactly equivalent to the attraction. If they were not exactly equivalent, they would fall upon the nucleus, protons, or fly away from it. Mechanically, the power which ejects electrons from the center is that revolving motion in their orbits, centrifugal force. In quantum terms, only a mathematical artifact named quantum accounts for an impossibility to leap from one orbit to another, unless a given quantity of energy is added. To give a name or a mathematical equation to an observation that does not explain it. Why don't electrons leave their orbit when attracted? Since particles are not particles today, but probabilistic existences, physicists say it is nonsense to imagine a particle falling upon another. It is not nonsense. Electrons are supposed to be negatively charged and protons positively. If so, they attract each other. If they do not, positive and negative do not mean anything. A mathematical equilibrium between two opposite forces is not a mechanical one, and in reality, as opposed to in equations, it would be impossible to maintain such an equilibrium. The smallest variation would destroy it. The smallest magnetic influence would move electrons from their previous orbits, and then either the attraction would be a bit stronger and they would fall upon the nucleus, or the attraction would be weaker and they would leave the atom forever. In both cases, your hand would disappear. Thank God physicists are wrong. The atom is not what they believe it to be. Its equilibrium is mechanical, not merely mathematical, thanks to the fact that all particles are at the same time positive and negative. In fact, these two words do not mean anything. Particles are at the same time attractive and repulsive, which is normal since we know that the only energy in the universe which gives off particles is magnetic energy. A particle is simultaneously attractive and repulsive with reference to any other particle. One aspect of its repulsive to the like aspect of the other. and attractive to its opposite aspect. They cannot be solely in a state of repulsion or attraction with another particle. That is the reason why your hand remains a hand. A particle is attracted by another, but also repelled, and with the same strength, and thanks to the synchronized spins that this generates, when you disturb it, it balances the disturbance by an acceleration or reduction of speed in its motion. We shall see this concerning atomic stability. So we shall not use the terms protons and electrons, but only nucleus and satellites. They are exactly the same particles, but in different circumstances. And that's basically it. But yeah, this guy, RAOUL Hateem, I think that's how you pronounce his name, is very interesting. He's talking about particles not being charged, but having a motion, rather, that keeps their equilibrium. And we can go on to see about okay, now here's the speed, stabilization, and atoms' mechanical consistency. Revolving motion works like an old-fashioned sling. While turning, speed increases, and the centrifugal force increases too. Since the gyroscopic phenomenon prevents any dislocation of the system, obliging motions to change only in speeds and distances in the same plane, thanks to the synchronism of spins, when the speed increases, the satellites tend to withdraw to further orbits. There, the attractive and repulsive powers are even smaller, hence spin motion decreases. When system speeds are so high that the centrifugal force is stronger than the resultant attraction, it tends to decelerate the entire system, increasing the distances. Then, if the distances are greater and the speeds lower, the centrifugal force decreases. Everything remains synchronized and consistent. It may decrease until this centrifugal force becomes weaker than the resulting attraction in the synchronized system. Then the satellites tend to fall down again upon the nuclei, diminishing the distances, increasing the attractive and repulsive powers, thus increasing the spin speeds, and so on. The centrifugal force recovers power and again tends to pull satellites away in greater and further orbits. Little by little, and yet almost instantaneously to our eyes, our atom becomes perfectly balanced, finding the appropriate orbits, permitting its satellites to turn at maximum speeds, where any jump in centrifugal force compounds any increase in spinning speeds. This provides the atom, or the planetary system, with a solid equilibrium of eternal harmony. Eternal harmony thanks to, on the one hand, synchronized rotations which oblige spin speeds to increase or decrease while distances change, or when something outside the atom intervenes, and on the other hand, to the gyroscopic effect, which obliges these disturbances to be evacuated solely by modifications in the speed of spin, and not by twisting the angle formed by rotation axes, which would tear the atom and make particles fall upon each other. Furthermore, if you add outer energy to an atom by striking it or heating it, or by compressing it, this increase in magnetic energy tends to increase the speeds, thus dilating the atom. But the atom resists this dilation in order to maintain synchronism. Synchronism cannot be broken and is the atom's resisting factor, in addition to gyroscopic effect. As soon as the intervention stops, the speeds decrease and the atom recovers its previous form. And that's why in my previous 5+ years of experimentation, I had got gold out of my furnace, but it wasn't actually gold because it had reverted back to the density of silver. So go figure. It is the same if you subtract by, for example, cooling the atom. See figure 15. The reverse occurs. Of course, compensating the contraction by an acceleration, since when distances are shorter, energy increases, increasing speeds, and making the atom recover its previously larger volume. This is especially important because this gives matter a real mechanical stability, whereas in the quantum atom, nothing causes any stability. And in the latter, particles are placed miraculously on very precise orbits, although they are not particles, so as to be in balance. The smallest variation would destroy this balance and subsequently the atom itself, with no hope of returning to its previous form. That doesn't sound mechanically sound to me. I'm sorry, that version of the atom does not work. And then he's got some graphs and a little experiment you can try, which I want to try. And then, of course, he talks about the official atom. Here we go. Particles are not particles. However, they are in attraction due to their electric charges, the source of which is unexplained. Some are positive, some are negative, and for mysterious reasons they build atoms. In order to maintain equilibrium, they are bound to have the same size, the same power, and the same number. What a coincidence! Electrons have no reason to spin, however they apparently do. Nuclei are not supposed to spin. They contain neutrons in order to increase their mass without increasing their electric charges. Electrons do not revolve around nuclei. They stand here or there when they are observed. However, they can quit an orbit and occupy another orbit if a sufficient package of energy, quantum, is provided, the source of which is unexplained. The quantum is the only stability factor in such an atom. Any disturbance exceeding a quantum of energy would destroy the atom forever. This prevents such an atom from being able to constitute matter, and deprives it of all the suppleness and adaptability it effectively needs in order to evolve in accordance with circumstances. Particles are associated with a wave which is explained by nothing. On the contrary, every magnetic particle, Hadam's atom, this guy's version of the atom, is obliged to emit alternately a north and south field, which is felt as a wave and is responsible for our ability to perceive it. Physics is obliged to invent antimatter to maintain the coherence of their theories, in order to ensure the balance of the whole mass of the universe. With the magnetic atom, there is no need to invent anything hypothetical to make theories consistent. Matter contains its own counterpart, since it constitutes within itself the opposition of two principles. Antimatter is within matter itself. And here is the Hatemian metaphysical atom. Here we go. Ready? All particles are bipolar magnets, and their origin is explained. They attract and repel each other. Their number, size, and power are unlimited. There is no need of miraculous coincidences for the atom to work and the universe to be. The distance between them is considerable, for obvious reasons. This distance is useless in the quantum atom, but indispensable in ours. Short distances cause particles to fall upon one another and prevent degravitation from working. Large distances cause atoms to manifest harmonious reactions, which are factors of stability. See, and I haven't done his experiments, so I don't know, but that seems to be the case from what he's telling us. Our atom behaves exactly like stars and planets, but they cannot be observed without interception, so their motion cannot be observed, and physicists think that they are not in motion. They are bound to meet in order to make up atoms, but they cannot fall upon each other and are obliged to spin and revolve. All this is clearly explained and inevitable. Their motion starts from steadiness, accelerates thanks to degravitation, and is stabilized thanks to orbital revolving. Generally speaking, particles spin in synchronized motion, which causes gravitation, permanent attraction, although repulsion also exists between them, and their orbital revolution. The orbital motion is also due to synchronized rotations. The orbital motion tends to dilate the atom, while gravitation tends to concentrate it, which prevents which provides it with its stability. The atom's motion accelerates or decreases in accordance with external influences. Without significant modifications, any concentration is balanced by an acceleration which dilates the atom, and any dilation is balanced by deceleration which concentrates it. So solidity resists external influences while retaining the capacity to evolve when necessary. Polar synchronized rotations in association with the gyroscopic effect of rotations are the two most important stabilization factors. And that is probably something you'd want to know if you're going to transmute elements. So that is the end of this presentation. Peace.